Okay, so let's make use of the law of sines here. We learned about where it came from, derivation, and now we're just going to look at an example of how it can be used. I mean, this sounds like fun to me, honestly. Going out in the woods, going out in the wilderness and looking at something using some trigonometry. But I understand if it's not, doesn't sound that exciting to you. But trigonometry is the tool that people use to understand the environment that they lived in. Ancient peoples used to figure out amazing things about the world. Oh, great. I'm missing an E here. All right, that's it. Can't even fix it. Maybe I can. Oh, look at that. Okay. So first thing obviously would be to draw a picture of what you're seeing, right? So we've got Erica walks off 200 meters due west. So critical here for you to have a basic understanding of northeast, southwest. So they're standing together and then Erica walks off due west. I'm going to put her over here. And what we know is that they're 200 meters apart. So that forms one side of our triangle. Then they're both looking at something. Now, for Erica, it's 10 degrees east of north. The way you read this is that this is my reference line and I'm going this direction, 10 degrees east of north. So I'm going east of north, that's this way. So from Erica's perspective, this is north and I'm going, she's looking this way. So that's 10 degrees. So what we can say if that's 10 degrees is that this is 80 degrees. Tabitha is a bearing of 78 degrees west of north. So again, from north here, 78 degrees west goes that way. This is quite a big angle, 78 degrees. And then from there, I can work out that the missing piece here must only be 12 degrees. So now I'm going to put it together. I've got my base here, 200, and I've got this meeting this, where this is 12 degrees and this is 80 degrees. Okay, so from there, I can use the law of sines because if this is 80 degrees and this is 12 degrees, then this has to be 88 degrees, right? Because the three angles need to add up to 180 degrees. So now I can figure out, call this X, call this Y. How far is Erica? That's X. How far is Tabitha? That's Y. And I'm going to set up my law of sines and solve it. Now, go ahead and press pause and see if you can finish that on your own. And if you need help, let's just follow along. Sine 88 over 200 equals sine 80 over t. So I'm going to go ahead and rearrange that. T equals 200 sine 80 over sine 88. And so solving that, me 197.1 meters, right? So this is the y distance. This is how far Tabitha is from the object. And then the other distance would be sine 88 over 200 equals sine 12x. So again, solving for x, x is sine 12 times 200 divided by sine 88. So that's 41.6 meters. So basically, to answer this question, I would say Tabitha is 197.1 meters away from the object, and Erica is 41.6 meters away from the object. So there's an example of using the law of sines. Going to see that in a lot of different situations because it's a very useful triangle solving tool. As long as you have a pair, so 3 pieces of information, and you have to have one pair, right? So it is possible to be given a problem where you don't have a pair. Let me show you a triangle like that, and that'll kind of lead us into our next scenario, which will be in the next video. So I'm going to give you 3 pieces of information, and I'm not going to give you a pair. 200 feet, 150 feet, and how about this angle? 30 degrees. Boom. No pairs. The 200 feet doesn't have its pair, the 150 feet doesn't have its pair, and the 30 degrees doesn't have its pair. So the law of sines does not work here, and that's what's coming next.